Hey everyone! So today I want to talk to you about an asteroid tracker that I built using Rust. NASA publishes a lot of APIs with all sorts of fun data that's free to use over at api.nasa.gov. One of those APIs is a near-Earth object service where users can search for asteroids based on their closest approach date. You know, just so you can see what's hurtling through space at thousands of kilometers per hour towards us. The data includes the object's name, estimated diameter, a flag for each object indicating if it's potentially hazardous or not, an estimated velocity, and missed distance measured in lunar distances. Also, fun fact, the gravitational pull of Jupiter actually saves Earth from being hit by a lot of the scarier asteroids. So yeah, thanks Jupiter. Originally, I had written this project a long time ago in Next.js because I had been doing a lot of work in JavaScript at the time, and I only recently got around to converting this to Rust. And because I wanted both the front end and back end in Rust, I decided to go with the Leptos framework. Leptos is a Rust web framework that does server-side rendering and then hydrates the page on the client using WebAssembly, i.e. WASM. So you write your components in Rust, and the framework figures out which parts run on the server and which parts get shipped into the browser as WASM. So one thing I really wanted to figure out how to keep was the original animated background that I had, which is this really cool slowly rotating view of the night sky with a few comments streaming across every so often. Originally, when I had this in JS, I felt like just displaying the NEO data on a boring page wouldn't do it justice, so making a background like this really brought things to life. In JS, I had used Three.js to do this, which is an amazing graphics library that I also used to build an orbital mechanics model a while back. I'll have to make a video on that project too at some point because it's really cool. So in Rust, this background works using a WebGL2 canvas using the WebSys crate, which gives you bindings to browser APIs. Every star has a position, a brightness, and a speed. On every frame, I update their positions in the shader. The ones that drift off the edge of the screen get recycled back over to the other side, and the brightness twinkles slightly so it doesn't feel like dead space. The whole loop runs inside a Rest component that mounts a canvas, grabs the WebGL2 context, and drives an animation frame loop. On the server side, there's a Leptos server function, which is just a regular async Rust function tagged with a macro that calls NASA's endpoint. I pass it a start date of today and an end date of 7 days out. NASA responds with the JSON blob organized by date, where each date has an array of near-Earth objects. I flatten all of those arrays into a single list, sort them chronologically by their closest approach epoch, and return the whole thing. Each object in the response gets deserialized into a typed Rust struct, name, estimated diameter in meters, a close approach array of the approach date, relative velocity in kilometers per hour, and missed distance in lunar units, plus the hazardous flag. On the client side, Leptos uses a resource to call that server function. While the data is loading, a suspense block shows a loading message. Once the data comes back, it gets mapped into rows for the table. Each cell carries two things: a display string that's formatted nicely and a typed sort key underneath, either an F64 for numbers or an I64 epoch for dates. That dual representation is what makes the sortable columns work correctly later. After I first got the app running in Rust, I was being a bit bad and just refreshing it over and over and over to test things. And suddenly the asteroid table just stopped loading. 'Cause yeah, it turns out that I hit NASA's rate limit. The demo key that's provided by default is capped at something like 30 requests per hour, and every time the page loaded, the server was firing off a brand new request. So yeah, my bad. So since that's a silly problem to have for data that literally only updates once a day, I added an in-memory cache on the server. It's just a lazy lock mutex hash map keyed by today's date. The first request of the day hits NASA's endpoint, parses the response, and stores it in the map. Every other request for the rest of the day gets served straight out of memory. No second API call. That fixed the rate limit issue and made the page load basically instantaneous after the first hit. Speaking of page load, it was taking just a moment for the animated background to load in, resulting in this really ugly white flashbang when first visiting the page. So I went in and defaulted the background over to a dark gray, almost black color that goes with the WebGL background so it's not as jarring. Also, if you see my other videos, you know I have no problem with AI tools as long as they're used responsibly, and I do use Claude CLI a lot. But I can't stress the importance of knowing what you're doing and actually reading the code it produces, and then edit it where needed. When using the CLI, I actually like the confirmation prompt for everything, and I keep that on so I don't miss reviewing the code. And if I'm not sure what a line is doing, I look it up, question everything. Constant vigilance. So let me point out a few places where discerning eye was important here. In this project, Claude tried to use Rust 2021 edition in the cargo toml, so I had to manually adjust that to 2024. Though this project doesn't directly use Rust 2024 features, you wouldn't have that if you didn't set it to 2024. And I would just rather have it on the latest anyways. If you're curious about the difference, though, between Rust 2021 and 2024, I'm putting a link on the screen and in the description that you can go check out. Next thing to point out is that the canvas and the background wrapper were initially having a bit of a tug of war. The original structure had two layers, a div class starry background wrapping a canvas class, starry canvas, the z index of 0 and position fixed that pins the background behind all the content was only on the outer div, not the canvas itself. So the canvas element was rendering on top of the starfield as just this ugly, opaque black rectangle, completely hiding the nice background. So the fix was to collapse the two into one, removing the wrapper div and moving all the positioning styles, position fixed, inset 0, z-index 0, pointer events none, directly into the canvas element. Now there's only one element doing both jobs, rendering the WebGL starfield and being correctly pinned behind the rest of the page content. Another thing is that unnecessary unwraps kept sneaking in. If you're not familiar with the unwrap function, it's the "I'm sure this won't fail" escape hatch in Rust. If it does fail, your program panics, and the message you get is something pretty useless called result unwrap on an error value. So while reading through the code, I caught a bunch of those in main RS and swapped them out for proper error handling. Next is portability. I have a few laptops and I switch between the machines just depending on whatever I'm doing. I do the majority of my coding on my Arch PC, but I also work on Windows from time to time, though Linux is much, much better in my opinion. And I wanted to see if the project ran smoothly on Windows. But when I cloned down the repo, the toolchain pieces didn't line up at all. So cargo Leptos needs the WASM unknown target for building the WebAssembly binary, and some of the build script dependencies wanted specific system libraries, and it just wasn't worth all that friction building it from scratch, so I Dockerized it. The Dockerfile is a multi-stage build. So the first stage uses the official Rust Slim image, installs cargo Leptos, copies the source in, runs cargo Leptos build release, and that spits out a server binary plus a site directory with the WASM bundle and CSS. The second stage starts from Debian Bookworm Slim, which is tiny and copies just those artifacts in and runs them. The final image is about 100 megabytes, and small but important, it doesn't run as root. Claude originally had it running as root, and that is a very good way to get had. I added a non-root user, gave it a fixed UID, shown the files to it, and switched into it with user app before the entry point. That's just basic container hygiene. If something ever gets messed up inside the container, it's not running full root privileges. Now, anyone can git clone and run the app using Docker Compose up build. So then I started looking into the actual table with the asteroid data to see how it could be improved. Initially, I was just displaying the results for the current day only, but I felt like I could display more. Turns out, NASA's NeoW feed That endpoint takes a date range, and I was just querying for today. So on that particular day, there happened to be only 5 objects. So I widened the range to 7 days. Today through today plus 7. That immediately bumped it up to around 30 rows, which feels like an actual dataset. I also added sortable columns. So every header has a little triangle indicator next to it, where you can click it once and it sorts ascending, click again, it flips to descending, click on a different column, that column becomes a sort key. The real trick is that each cell carries both a display string and a typed sort key underneath, a real F64 for numbers and an I64 epoch for dates. So the visual stays pretty, but the actual comparison is on the raw values. Dates sort chronologically, numbers sort numerically instead of alphabetically, and the whole thing is reactive. So when you click, there's a Leptos signal that fires, the rows resort, and the table re-renders without a page load. So yeah, all in all, I would say this is a successful port to Rest. It's a full stack app with Leptos and WebGL2. It's got the custom shader starfield, an in-memory cache, proper error handling instead of just crazy panicking unwraps, and a multi-stage Dockerfile that runs as a non-root user, and sortable headers with the typeware sort keys. If you want to try it out yourself, the repo is linked in the description. If you have any questions, just feel free to drop them in the comments below. Until next time, bye!